Hey everyone, welcome to part 2. This is a shot of me at my CNC machine. I'm going to go over one of the most annoying things about making distros, and that's the O-ring channel. Now, if you have a high production facility or you have a very high-end CNC, it's very easy for you to surface this acrylic, which you'll normally do, especially on clear. And with the high-end surfacing bits, you can get a very clear, almost unnoticeable the fact that you finished it. For a hobbyist CNC, that's not really possible. You're gonna have to do a lot of sanding afterwards. And for something that's glossy like this, it's not really gonna be possible to get that finish back, even if I'm sanding it over and over again. So what I'm doing here is I'm taking the caliper and I'm measuring the depth of that O-ring channel that I've milled so far, and I'm checking for variance. The original audio for this was cut out due to my mic wire was picking up the radio for some reason. But essentially, I have a very huge variance on this piece. So in the top left-hand corner, it's almost 1 millimeter variant than the bottom right-hand corner. And what I'm trying to get is kind of a 1.2 all the way around. Unfortunately for this piece, it did not seem like it was something I was going to be able to achieve, even if I, for example, split the paths and cut certain part of the path separately. It just becomes a lot of work. So while I did try it for this piece, eventually what I ended up having to do was to scrap the entire thing and start with another piece. Obviously, this piece can be used for other items. I can surface it down and then use it for something else. So it's not gone to waste, but that is one of the frustrations with making distros. So when I had the pump res mounted on my test plate, I noticed there's something that I missed. The pump looks like an eyesore without something covering it. And also the wire was just dangling. So I've added a wire to, a hole on the pump distro design to allow the wire to pass through. Now, I've also decided to make a pump cover. This pump cover is pretty easy to make. All you really have to do, like I've done here, is, let me just show one of the original dimensions. I take the diameter of the pump, I measure that, I give it a 0.25 additional millimeter gap, and then I give a basic shape. I measured, this is about 70 millimeters, so when it attaches on, it looks kind of natural. I extrude it out into a block, and then I give it some shaping so that it looks more like the water cool reservoir, right? In the back, I've given it a small opening where I can pass the wire through for the PWM and the Molex. Obviously, the Molex will require depinning before it can pass through, but that's easy enough. And then in the front, I've added a water cool logo. And that kind of just ties it in with on brand. And I think something small like this is a nice touch to have. While I could machine this, but you'll notice it's 37 millimeters. This is another 3. So it's 40 millimeter thick acrylic. It's extremely expensive and not worth it if you can 3D print. For anything you can 3D print, you're better off 3D printing than machining, unless you have to machine it for whatever reason it may be. Because, subtractive manufacturing, which is machining, is a lot more expensive than, additive manufacturing, which is 3D printing. For those of you that are into 3D printers or getting into 3D printers, Fusion is a software that can generate G-code for your 3D printer, or you can just, it's so easy. You can just come here. I go to, I don't know if the menu is going to show up. You just export this directly to like your slicer. So yeah. So if you guys, just used to printing other people's stuff, you can also learn Fusion and make your own prints. So the distro that holds the reservoir is done. O-ring was a total pain on this one due to the unevenness of the acrylic. But now you can see that I've mounted it. I've put the 2 tubes that run from the reservoir itself. And for those of you that are wondering, let me move a little closer here. You can see that I am really close here. That was actually not by design. I didn't anticipate the fan being so wide, and I didn't even think about this portion. So I got really lucky. It's like not even a millimeter gap. I'm using the original bracket, so when I take it out, I slide it in and I push up, right? So I'm using the stock fan bracket to mount that
whole entire piece. What I'm going to work on now is getting the tubes that go from here, like let's say here to here, right? And then here to there. Then I'll start working on the other piece for the CPU block, and that connects these two also to complete the loop. The radiator is a little bit loose because I'm moving it so I can line it up here. But that pretty much covers the reservoir portion. For those who are curious, this is a 3D printed cover that's kind of mimicking the original design. It hides the pump, and it also makes the wire flush. Like, I have another hole here where the wire runs through. That's why you don't see any wires at all. But yeah, so that's where I'm at now. I'll pick it up when I have at least these tubes connected to show you guys how it looks. And then I'm connecting these tubes first so I can have an idea of how much space I have to run these tubes, and the front piece that I have kind of floating. I don't know floating, but the stock mesh kit for the front, you can see that there's screw holes tapped here. So what I may do is I may just cut a piece of aluminum, tap it, and then use that to mount whatever I have here, so I have some structural rigidity. Because this is, without this part as well, you can see this case is not as good as the Evo, the smaller one, the non-XL. It doesn't seem as rigid, so I might do something here, just kind of blend it in. You might not even realize that's what it's for. But yeah, so I'll pick it up once I got the other tubes in, so you guys can get a look what it looks like. All right, so I have the tubes in for the radiators, well, at least one of them, and for the GPU. Now I put the red tool here just to show you guys this is not a black and white, although it does look very black and white. So I think for fluid, I'm gonna add some color. I'm not gonna add color on the cables. I'm still gonna leave just black and silver or carbon or something like that. As for the metal tubing, I've had folks ask me before how I deal with metal tubing. It's very simple. First, you will need a pipe cutter. Do not use the ones the brands have. I think the EK one's okay, but I buy this one from Ridgid. It's small, it's easy to store, and it's very sturdy. It's much more sturdy than something you would get from one of the brand's rebranded pipe cutters. Now, the most important thing about these is that you have a nice wide surface area for you to lay the tubing on, and then you just clamp on the tubing and you turn. It's just a regular pipe cutter, nothing too special about that. Now, aside from that, you're going to also need something called silicone grease. Do not use Vaseline, okay? I use this to help push the tube into the fitting. Even though if you chamfer it, you still need some grease to make it easier. This also works for acrylic PETG. Just, you know, be kinder to your O-rings, right? And you don't have to like mash them in. So, because what happens when you mash them in is they start cutting the O-ring like this. I don't know how well you can see that, but this fitting has a cut O-ring, and that's from pretty much taking a tube and forcing it in. Okay, sometimes even if you chamfer the tube, you will still do this to your O-ring if it's not lubricated. So what I like to do is I use the grease. I have this O-ring tool from Bits Power. They sell them in different millimeters. This one's a 16 millimeter. And what I do is I just take it, I lube the O-ring tool, and then I just stick it into the fitting like this, and I turn. And that applies a nice even coat inside the O-ring, so I don't even have to get my hands dirty. And yeah, so that makes it super easy. And to chamfer the pipe, you can't use the kind of bit you have on for acrylic and PETG. You have to use sandpaper, okay? Now, you can sand away all day with different grits, and that's really fatiguing because you'll need like 600, 800, you know, start with a 400. You know, it's just a painful process. So, you get a handheld belt sander like this from Wen, right? It's on Amazon. It's like $20-something, I think, last I checked. You can get different grits for the belt. I only use one. Don't even need different grits, to be honest with you. I just use the one that came with it. And then I just hold it like this, and then I just turn. And I chamfer it as you go. You will also need another tool. Sometimes when you cut the pipe, it's a little bit jagged, edgy, and uneven, especially on the inside. And what this tool does is it kind of just cuts the edge, okay, and makes it smooth. But technically, you can get away with just using the sander. I've never really seen any kind of buildup inside that requires it. But this tool, I also link on Amazon. It comes with like 20 blades. I've never even had to change the blade. But that's pretty much all you need to work with metal tubing. Also, metal tubing, especially pre-bent, is very expensive. So for fittings like bits power, be very accurate with your measurements, because the tubing actually goes, for example, if I were to use this fitting right here, this tubing actually goes all the way into this part of the fitting, not here, but actually here. So your best bet is to, I would say, use like acrylic, like PETG tubing, because it's easy to bend. Bend into shape, get the length you need, and then replicate it onto the metal tubing, especially the pre-bent. Because if you mess this up, once you cut something short, you can't go back. So these things are usually like 4 for $60 in a 4-pack or more. So don't make that mistake. Okay, I've done it enough with these fittings that I kind of know. The way I measure it is, I have a lot of scraps, so I hold one up, I get a general idea, and then I measure the difference with a millimeter ruler, and then I mark it and I cut it. But you can still fuck up, right? So, like this one has a little bit, probably 1.5 to 2 millimeter extra down here that I'm a little bit short. It works just fine, but what happens is when it's short, is it can move like this. See, like, you see that movement? Like, technically all the tubes can move a little bit, but this is too much, right? Like, it's not going to come out, see? But if I pull on it enough, I can make it come out. This is what happens when you don't have that exact amount, especially on a bended tube. So that's why, you see people with sagging tubes and stuff on Facebook and Instagram all the time. That's just a leak waiting to happen. It may not leak if you don't move the machine, but the moment you move this machine around, you lift it around, this can definitely come out. So, it wasn't easy for me to yank it out, but it can come out. So make sure you always are getting the exact length. And that's very difficult to do with certain fittings, because fittings like this, there's not much room for you to mess up. Because if you look at it, I know I'm ranting here. If you look at it, the fitting goes about what? That's about 5 millimeters deep, right? You need at least 4 millimeters of that. And if you have 1 millimeter gap, it becomes very difficult on a bend to get it fully inserted without working around it. That's why the new generation of bits power fittings are so much nicer, because they have a collar with a flat base like the TT fittings. This is what makes these C Pro fittings so useful, is that you can just easily line it up to there. You don't need to kind of move around a collar that might get in the way. And also, if you notice on fittings like this, you have 3 O-rings, and what is that, 2 O-rings in there. You have a good amount of depth to adjust that tube. But for something like this bits power fitting, the margin of error is much smaller. The margin of error on an EK fitting is a little bit larger, but still, like this one, I will redo it, because I was off by like what, 1.5 millimeters. So it goes to show, small things do matter. All right, so I'm gonna tilt the machine on its back, and we're gonna try to measure the front. I haven't figured out how I'm gonna measure the front yet. I'll probably use the front glass, and we'll see how that goes. So I have the build on its side. I put some masking tape on the inside of the glass. I'm gonna use the glass itself as a reference point, all right, for me to draw my lines. Kind of like if I put this glass anywhere in this plane right here, it'd be the same thing, right? So I have a fitting in tube going from the radiator to the glass, and I have a tube going from the CPU block to the glass. Now, I only need to do one set of holes, because I know that 2 holes on the CPU block are 28 millimeters apart. I know that this radiator is 25 millimeters from the edge, and this radiator is 25 millimeters from this edge. So I know that these 2 port locations on each radiator are in the same, in this case, y-axis. Okay, the x-axis obviously is adjustable. Same goes for the CPU block. The y-axis is adjustable, the x is not, right? So, because the x is the location where the block is compared to the case itself. I do use a digital leveler just to make sure that this is level all the way across, so that I end up with something that's actually dead straight or close to it. So what I'll do right now is I will mark where these are, right? And then I will use the glass as a reference to find the distance between these two holes, and then, you know, once I have where all the ports are going to be, I can obviously, like I said, make those adjustments to the X or Y axis when creating what the final piece would look like to combine these two together.
Okay, guys. This is the front distro, essentially. I know it looks finished. I didn't go through the whole fusion process because I did that for the reservoir distro. So for the interest of saving time for everyone to watch repeat things. So pretty much what I've done here, last time I talked about measuring the ports. I came in first, and hold on, let me show you guys the sketch. I put in the dimensions of the glass, which is this. Then I put the ports on. Alright, so this is how I like to do it. So I put the ports on where they were, and you know, I think, let's see, let's rotate it correctly. So when I had the computer on the desk, was it like this? Yeah, it was like this. I think so, right? No, sorry. It was like this. Okay, so it was like this when I had it on the desk, right? So I had the CPU block here, I had the radiator here, and then these ports, I remember I was saying that I can decide the X, but the Y is static, right? Because the radiator port is over here, it's not going to change. So once I had that in, I drew in my water channel design, right? I decided to kind of go with this W for water cool, right? Which is the company that's sponsored all my blocks and radiator stuff in here. So just give a shout out to them. Then I draw in my spacing for my O-ring. This is essentially, as I was going over before, this is the channel that's between the O-ring and the water channel, and then I have the channel for the O-ring itself, and then I have the screw holes which I'm projecting to the lid, right? So this pretty much covers the bottom, so I'll show you guys the bottom, and I'll hide the original ports, right? Same thing as before. I project the distance past the O-ring to the top lid, and then from there I create the screws, and then I create the ports, right? For this one, I have ports on both sides, right? Not just the top, right? So these are the ports that go to the CPU, and then these are the ports that go to the radiator. So I have ports on both sides, so when I machine it, I have to take it out, flip it around, and so forth. And then afterwards, you know, because when I originally drew it, I made a whole block distro, right? And then this is the design I draw in here to make that design shape that you see at the very end. And we can go take a look at how it looks after it's done.
So here we have the piece completely made. I have it on temporary extension fittings. For those of you that really only pay attention to, say, like EK fittings, or I guess if you buy into the Corsair stuff, which is just bits power stuff, you may not know these adjustable fittings. They come in different lengths, and they're pretty much very crutch in a lot of build situations. But I have them on here just for now, just so I can get the height correct, right? Because I'm trying to line these two up with this tube. Well, I'm gonna have to cut it down from the CPU block. Once I have it lined up, I will make the final adjustments here. I'll measure how long that tube needs to be, and I'll cut it out. So that's pretty much the plan here. You notice I'm super close to the fan. My design, I didn't exactly anticipate being that close to the fan. I did want this part a little shorter, but then if I made this part too short, this part is going to be too long, and I can't exactly move. I guess I could have moved this up a little bit more and then kept this down, but I don't know. I think it strikes a nice balance in terms of length and positioning where it is. But yeah, so I'll get it in there. I'll take a look how it looks. If I have to recut a new piece, I'll do that. So let's give it a shot.
So once again, having the CAD for the case is extremely helpful. What I've done here was to kind of, while I'm waiting for the CPU to show up, I decided I'm going to start working on some of the other visual elements, right? First, I decided to add an additional display screen that's a little bit different than, you know, what you would normally see when people try to put a screen in there. So what I did was I took my inspiration from the Heatkiller CPU block that I'm using, right, which has this shape. And let me just hide the case. You can see where it's going. It's going on the rear of the case, which I'll show you guys obviously once it's also mounted. But anyway, so just a quick description of how this is working here. I'm going to put a round screen in here. So what I've done was I've originally made the cutout dimension for the screen itself. These are inlays that I'm going to make, and you can see here if I can separate. Can I separate this? Why is it not separating? I did not join them. That's strange. Okay, so what I'll do is I'll just remove the rear plate. So this piece right here is going to be one piece of acrylic. Obviously these are chamfered along edges. It's been cut out to, I think, 73 millimeters on this to fit the LCD screen that I'm using, which is a circle one, as I mentioned. I've also pocketed this part for the inlays itself. These are obviously chamfered edges as well to match the Heatkiller block, which has the, you know what, let's see if I can bring an image of that up here. So back to what I was saying. So here's the Heatkiller block. You can kind of see where my inspiration's coming from, right? So I got these chamfered edges like you have on here, I have it on here, okay? So I'm repeating the same kind of edge design, and it obviously a circle for a big port, right? But this is a screen. Now if you're wondering how I'm going to hold that screen in there, it's very simple. If I flip it to the back, I've made a couple things. One, I've made a groove here, which will be on the rear cover as well. These are M4 screw locations to go into where the 140mm fan will go. These are pocketed for in case I decide to use magnets instead of screws, right? Just, you know, while I'm at it, I might as well. And if I put on the rear pad, you can see that this is going to be a 3D printed piece. Once the screws go into here, right, it therefore makes it a solid piece. And then I'm going to put some adhesive over here. This is to run the wiring for the screen, and the screen will stay put and won't fall out, right? And if I want, technically I could use screws, screw this together so it becomes one piece, then use magnets to hold it to the case. But you get the idea. It's just about creating flexibility. So that's what this piece is going to look like, and yeah, pretty much. So I'm going to go make this piece now. I'll show you guys once it's done, and I'm going to think of what else I can do while I'm waiting for that CPU to be released.
So here we are. We have the front distro assembled, the one that is combining the CPU and the radiators. I also have the design piece installed that I showed you guys in CAD. But other than that, all the wires are also installed. These are cable mod cables, and all the front panels connected. So everything's all wired up, ready to go, except for I don't have the CPU. There is a CPU in there at the moment, but that I think it's a 7900X, might be a 7950, I'm not sure. But it's one that I put there just to kind of test boot the system dry, and also make sure that I have my tubing in the right positions. But on Thursday of this week, on the launch of the 9950X, which due to an unfortunate delay, I will have that in there on Thursday. And, you know, when I fill it, we'll run some, you know, kind of benchmarks, etc. But yes, so you'll notice that the motherboard, I don't know if you can see it on camera, does have the red lighting on. That's the default I have it to. So I'm thinking that looks pretty good. So I might do like red lights on the fans, maybe clear red fluid, you know, maybe even blue. I don't know. So if you guys like blue or red, put it in the comments. I'm still undecided. I only wanted that little bit of color so it doesn't just look black and white like it does right now. So with that said, let's zoom in a little bit to the, well, I guess the rear feature part that I showed you guys in CAD. So here I have it pointed at the rear screen that I created. It is currently playing a water cool kind of a B-roll for their new Mora. This will obviously play statistics or whatever it may be when the system is up and running. It does have its own internal storage. So in the meantime, it's just playing whatever video there is on that internal storage when the computer is not powered on itself. It does receive power from the internal USB, which remains on from the motherboard. That obviously can be adjusted in the BIOS if you really wanted. But other than that, that pretty much wraps up where we are right now. The next time, well, this Thursday, this will be finished. I will install the new CPU, etc. And then on Friday, probably the video might be on Friday, you guys will see the B-roll and the whole finished system, along with some initial Cinebench, etc. All right, so thanks for watching. Stay safe and take care.